Okay. We have got measurement of volume of liquid today. That's why we have learned how to measure the volume of some solid object. If it would have been a sinking object, it would have directly sink in the water. We would have kept in the water like this. So again, we have kept stone as solid. And if it would have been a floating object that floats in water, then we use a stone to measure the volume of that object. Now today we are going to do the measurement of volume of liquid. We will measure the volume of liquid by a method. Right? It will be the same. So we'll use a cylindrical tank. If we have to measure the volume of the liquid, we'll use the cylindrical tank. Just for example, we have got a bottle. We have got a bottle, and in the bottle we have got water in it. And that will be a half also. That will be quarter also. That may be any other. Right? So that even on the structure, that could be anything. Just suppose that we have got water in the bottle. Now we want to measure the volume of the liquid, volume of that water in the bottle. Right? To measure that volume, we'll not just tell it like by seeing it. Okay, this is about 400 cc. This is 500 cc. We will not tell like that. For that, we use our instrument. Right? We use something like measuring cylinder. Look at that. We have got a figure. Yesterday also we have used that measuring cylinder to measure the volume of solid. Again, okay, that was fine. We have kept that solid in the water and we have measured it. But now today, yeah, we will keep that water in the cylinder and we'll just read the reading. Just a simple step. Right? We will just read the reading only. Either while if we put water, okay, if you have got water in that bottle, then we'll keep that water in the measuring cylinder and the cylinder also, and we will read the reading. Just for example, here we have got how much reading in figure 1.10. What is the reading? What the volume of that water present in the cylinder? Kati hola? How much is it?
400.
Okay, it is 400 cc, and it has given something like incorrect, and it has made 3i. Right? The meaning is that whenever you are taking the reading, again, you should have to look it very straightly. If you look it from a little bit higher, then you can get something like incorrect reading. Right? The reading may not be accurate. If you look it from lower surface, the reading may be incorrect. What should you do? You must look it straightly. And whenever you are taking the reading of volume of liquid, you must take it straightly. You must look it straightly. Right? Here also the same condition. You must have to look straightly from your. You should not have to look it from up, from the other part. Neither you should have to look it from down also. It must be very straight. Either the more straight you will get you will look against the straight the more accurate is the result within a body accurate the results. Right? But it doesn't happen with everything again. Okay, this was fine. Look at the upper surface of the water again at this place. Annotation, let me bring it. Let me use spotlight. So if you look at this upper surface, okay, it's very straight, right? But it doesn't happen with anyone. And the major fact here, it has written about mercury. Look at here. But I should lie at the upper meniscus for the liquid such as mercury. If we keep mercury in this, right, then it will be somewhat a different thing, right? It will seem like this. Let me draw it. If we put mercury in it, it will look like this. Let me make it a little bit curved. Right? And if you put kerosene and that type of material, it will be seen like this at the level of water, the level of liquid, not water, the level of liquid. If it is water, then it will be straight, water is straight on the again. And if you put mercury, it will come up, the label will come up like this, will rise up little bit higher at the middle like this. If we put kerosene mustard oil, the label will drop a little bit lower like this. I mean, kerosene mustard oil, if we put the mercury, then it will go up. And while taking the reading, now, while it was water here, you had seen it straightly. But if you want to take the reading of this mercury, you must have to look at this. Yeah, I at the upper meniscus at this place. That means it will be a little bit off. The mathematical surface map. If you want to take the reading of the mercury, a volume of mercury. Similarly, if you want to take the reading of the kerosene, then you will look at the lower meniscus at the surface, at the lower surface. Let me make it straight or accurate. You will look at this lower meniscus if you want to take the reading of the volume of the kerosene. Either. Got it? How to take the reading? Again, it depends on the material. Right? It depends on the liquid which we'll use. And if you want to take the reading, water, you look straightly again at the middle point at from the surface. If it is mercury, you look at the upper surface as it will seems like this. If you want to know how does mercury and mercury level looks like, mercury surface look like, mercury surface you can go to the hospital and look at the mercury thermometer, right? You can see there clearly that the mercury has got upper meniscus. The mathematics the answer, right? The surface of mercury. The mercury surface again, so answer, but kerosene ki answer, answer, answer. Then measurement of volume of gas. Again, the another thing we have got, we have learned to measure. We have measured the volume of solid, right, by keeping it the water. Again, now we have learned to measure the volume of liquid. Now we have got measurement of the volume of gas. How to measure it? Again, gas the volume. So we have got some materials required here. Right? We have got a measuring cylinder glass. We have got a steel tumbler, water, and a top. Right? And this is the cylinder. Again, this one. This a little bit slanted one of the Kalgira. So again, that is the measuring cylinder. This lower one, this is a tumbler. Top. And we have got here water and a water set, and we have got here a tumbler. Right? So these are the instruments which you use if you want to measure the volume of the gas. Right? So how to measure it now? And these are the materials which are required to measure. But how do we do that? What is the procedure to measure the volume of the gas? What the process? What the phenomenon for that? Right, so we'll go with that also. Method, fill a tub with water. Now you will take a tub, this one, right? This lower one will take this top. Let me go on drawing. You will take a tub and will fill it with water. And let us suppose it is filled with water. I cannot do it very accurately, right? But imagine, let's consider that here is water. Right? These are the water in a tub. I keep water in it and fill a measuring cylinder of glass and place the inverted tumbler carefully in the top ring. Now fill a measuring cylinder of gas. Keep a gas and place an empty tumbler, invert it into the water and adjust the tumbler in such a way that here are the tumbler comes into the measuring cylinder. Now it is the volume of the here in the measuring cylinder. Now after you do it again, you will fill a cylinder with water. Again, you have given cylinder like we'll do that. And look at here. It is filled with water. In this cylinder, you will fill that and you will keep inverted. I उल्टो गरेर राख्छ okay imported means उल्टो गरेर राख्नु है you will keep import it into the water in such a way that the water of the cylinder does not come out like if you like let us say example of glass if you want to keep the water of the glass into the pocket so that the water of the glass won't escape again जुन ग्लास भएको जुन पानी हुन्थ्यो त्यो फुकेर नगइकिन के छ त्यो पकेर राख्नु पर्यो उल्टो पारेर हो किन तर पानी खस्नु भएन है फेरि the water must not escape out from the glass which will have to keep in such a way but in what तर उल्टो राख्नु पर्यो त्यसलाई के गर्छौ अरबाले okay now after that what will you do you will place an empty tumbler okay in that tumbler in this one in this apparatus we have got air inside we have got gas inside it and there will be gas right then you will invert that and while inverting that what will happen now the air of the tumbler comes out into the magic cylinder look at it the air from this tumbler will gradually move toward the cylinder and occupy some space. Now you will think where has the water of this surface has gone? There was water at the beginning again. Yeah, if you look at here, there is water. Where has it gone? Look here in tumbler. Okay, it has gone to the tumbler, and the air of the tumbler has gone to the what cylinder. Now you can take the reading. Now tell me what the reading of this volume of this year, what the volume of this year. कति भयो त
100 cc.
100 cc. Okay, you can take the reading like this. Hey, remember this, right? The air from the tumbler has moved toward the cylinder. The only thing you should be careful here, what you must be careful about is while making that cylinder inverted and cylinder उल्टो पारेर राख्दाखेरि the पानी के हुन्छ खस्नु भएन है no drops of water must be escaped out from the cylinder like के हुन्छ ग्लासमा के हुन्छ छोपेर गर्छौ नि त छोप्छ हातले अनि उल्टो पार्छौ तल राखिदिन्छौ into the bucket राख्यो and while you go inside the water पानी भित्र के हुन्छ पुगेपछि छोड्दियो भने के हुन्छ the water of that glass won't come out त्यस्तै गरी के छ cylinder also है छोप्दिने it is not possible to cover that cylinder with the hand. You can use other thing like some cardboard paper. Okay, you can use such kind of thing. Cover that. I should cover garden. Import it. I go to barrier. Can inside the top again top with the then leave it. Right, the water won't come out. So panic is a byron is right. But after keeping tumbler again, tumbler again the air from the tumbler will go to the cylinder and the water from the cylinder will come out. Right? In this way, you will find the volume of the gas. Right? So understood how to calculate the volume?
Yes, sir.
Yes, sir.
Okay, then. Now we have got the exercise part.